Dear all, in this video we are going to discuss about the topic Hadoop under Unit 5, Cloud Technologies and Advancement. So cloud is an open source framework model. It is developed by a Don Cutting. A man developed a Hadoop. His son was playing with a toy, elephant toy. It is named as a Hadoop. So once he developed a model, he named the model as a Hadoop. So why we are going to use Hadoop is used for distributed processing of large data sets across the clusters of computers using simple programming model. Hadoop is designed to scale up from single server to thousands of machines, each offering local computation and storage. Hadoop runs application using MapReduce algorithm where the data is processed in parallel on different CPU nodes. So the Hadoop application runs using the MapReduce algorithm. Hadoop equal to MapReduce plus HDFS. HDFS is Hadoop distributed file system. MapReduce is processing. HDFS is storage. So Hadoop is processing of data which is stored in several computers, that is clusters of computers in a parallel form. We are going to process the data. So processing of data in a distributed file system of storages in clusters of computer we are going to process. Uses of Hadoop. So what are the uses? Which are the websites you are using the Hadoop? Why they are using? There are variety of uses. For example, for behavior analysis and targeting. eBay will be using for search optimization. Facebook for reporting, analyzing, machine learning. LinkedIn website, Twitters. They are also using the Hadoop open source framework architecture. So we are going to discuss about Hadoop architecture. How the architecture runs. Hadoop has a master-slave architecture for both storage and processing. Hadoop framework involves the following four modules. Hadoop Common. These are Java library and provide file system and OS level abstractions and contains the necessary Java files and scripts required to start Hadoop. Hadoop Yarn. This is a framework for job scheduling and cluster resource management. HDFS, a distributed file system that provides high throughput access to application data. Hadoop MapReduce. This is a system for parallel processing of large data sets. This is a framework for Hadoop, that is MapReduce, HDFS, Yarn framework and common utilities. So Hadoop consists of a framework that is only two components, that is HDFS and MapReduce, distributed storage and distributed computation. MapReduce engine. The MapReduce engine is a computation engine running on the top of HDFS as it is a data storage manager. HDFS is a distributed file system inspired by GFS that organizes the files and stores their data on distributed computing system. HDFS architecture has a master-slave architecture containing a single name node as a master and number of data nodes as workers, that is called as slaves. HDFS. Why we go for HDFS? To store a file in this architecture, HDFS splits the file into fixed blocks of 64 MB and stores them on the worker, that is on data node. Mapping of blocks to the data node is determined by the name node. The name node is called as a master, which manages the file system, metadata and namespace. Namespace is the area maintaining the metadata, and metadata refers to all information stored by a file system that is needed for overall management of all files. The name node in the metadata stores all information regarding the location of input splits / blocks in all data nodes. Each data node, usually one peer node in a cluster, manages the storage attached to the node. Each data node is responsible for retrieving and storing its file blocks. So size of the file boxes, it is fixed, it is 64 MB. It stores on the each and every data node. The name node is the metadata which consists of all the data nodes. HDFS features. Distributed file system has some special features, that is performance, scalability, concurrency control, fault tolerance and security requirements. So HDFS is also used for fault tolerance. To reliably store data in HDFS, the file blocks are replicated in the system. The HDFS stores the file as a set of blocks. Each block is replicated and distributed across the whole cluster. The replication factor is set by the user and it is 3 by default. So the replica placement, the placement of replica is another factor to fulfill the desired fault tolerance in HDFS. Storing replica on different nodes, that is data nodes located in different racks across the whole cluster. HDFS stores one replica in same node, the original data is stored. One replica on different node but in the same track. One replica on different node in a different track. The heartbeats and block reports are periodic messages sent to name node by each data node in a cluster. So the data can be viewed at any point of time that there is a no name in the form of loss, because the data can be stored in various environments and various places and various data nodes and by the name nodes. The receiver heartbeat implies the data node is functioning properly. Each block report contains a list of blocks on data node. The name node receives such messages because it is the sole decision maker of all replica in the system. HDFS will give a high throughput. Applications run on HDFS typically have large data sets. Individual files are broken down into large blocks to allow HDFS to decrease the amount of metadata storage required per file. The list of blocks per file will shrink as the size of individual blocks increases. By keeping large amount of data sequentially within a block, HDFS provides fast streaming reads of data. In HDFS, it consists of two operations, that is a read operation and write operation. To read a file in HDFS, user sends an open request to name node to get the location of file blocks. Each file block, the name node returns the address set of data nodes containing replica information for the requested file. The number of addresses depends on the number of block replica. The user calls the read function to connect the closest data node containing the first block of the file. Then the first block is streamed from the respective data node to the user. The established connection is terminated and the same process is repeated for all blocks of the requested file until the whole file is streamed to the user. This is called as a read function in HDFS. The HDFS client will open a distributed system and get the block location from the name node. Next, it reads the FS data input stream. Then it go for the reading the data node where the data is present, and it will read simultaneously another data node, and it gives a return back and message from the data node. Then the close command will be coming from the HDFS client. This is a read operation in HDFS. Then we go for a write operation. The write operation, if the file does not exist, the name node notifies the user and allow him to start writing data to the file by calling the write operation. The first block of the file is returned to an internal queue termed the data queue. The data streamer monitoring its writing into a data node. Each file block needs to be replicated by a predefined factor. The data streamer first sends a request to the name node to get a list of suitable data nodes to store replica of the first block. The streamer then stores the block in the first allotted data node. Afterward, the block is forwarded to second data node by a first data node. The process continues until all allocated data nodes reveals the replica of first block from the previous data node. Once the replication process is finalized, the same process starts for the second block. So we will be by block we will be doing a write operation in HDFS. So this is called a write operation. Initially, the client will give a first command create a distributed file system. It will go for a name node. Then we start writing the operation FS data output stream. Then it go for each and every node or data node and write packet and give the acknowledgement. Automatically, the pipeline of data node will go for the second data node by the same command write packet and will get the acknowledgement. Then the second node or data node will go for another data node by block wise by the same thing write packet and get the acknowledgement packet. After that, the last command from HDFS client is close will be coming. So in this video we have discussed about Hadoop architecture, which consists of MapReduce and HDFS, and what are the fault tolerance and throughput in HDFS, why we go for HDFS, and what are the futures in HDFS, and what are the operations, that is the read operation, write operation of data, how we are processing in the HDFS through the diagram we have discussed. Thank you.